Hi class, welcome to lesson 64. In this lesson, you're going to be able to identify isomers of alkanes, alkenes, or alkynes, and construct isomers for alkanes, alkenes, and alkynes. I recommend you use guided notes as we're going to be using a lot of structures today, but you're more than welcome to take notes on your own and make sure you bring any questions you have to class. Let's get started. So an isomer has the prefix iso, meaning the same. We learned about isotopes earlier in the year, which are elements that are the same because they have the same number of protons. They have different masses because different number of neutrons. Isomers are compounds that have the same molecular formula, but they're arranged in a different structure. This different structure will always give them different names and different physical or chemical properties. Here in this example, you can see we have the straight chain hydrocarbon butane. Its formula is C4H10. We have its isomer, methylpropane. So methylpropane has a different name and a different structure, but both of these have the same formula, C4H10. So take a minute to look at these structures and see if you can find the compounds that are isomers. So here, the first thing we have is C4H10, and we can see that the item to its right is also C4 and H10. So these are a set of isomers. Now, when we look at this bottom structure on the left, we can see that we have 5 carbons. So this 5-carbon structure cannot be an isomer of butane. And so, but we can see that all of these structures have the general formula C5H12. So these are all isomers of pentane. So by now you should be able to identify an isomer. And now let's talk about how we draw an isomer. When you draw an isomer, you want to make sure that your structural formula has the exact same molecular formula for the isomer, but you need to draw a different structure. And basically you know that if the name is different, but you have the same molecular formula, then it's definitely an isomer. And if you have the same name, it's definitely not an isomer. So there are 2 ways in which we can draw an isomer. One way is to find and move either the multiple bond or the branch over 1 carbon. And then the other way is to take a terminal or end carbon from the parent chain, remove it, and attach it 2 carbons over. And it's really important to remember we never attach it to adjacent carbons. So always 2 carbons over. So let me show you how to draw the isomers of hexane. Let's see if we can draw the isomers of this structure. So first let's name this structure and find its formula. Its formula is C6H14. So this structure is called hexane. So the easiest way to write an isomer is to take an end carbon. So I'm going to take this carbon right here and remove it. So instead of 6 carbons, I now am going to have a chain of 5 carbons. But an isomer needs to have the exact same molecular formula. So I'm going to take this carbon and move it over not 1, but 2 spaces. So not on the new end, but here. I'm going to place it here. Now I need to add my hydrogens, making sure every carbon has 4 bonds. And I'm going to count as I go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this has the same formula, but it's a different shape, so it should have a different name. So my parent chain has only 5 carbons, and it has a 1 carbon branch on the second carbon. So this is 2-methylpentane. And we can repeat this process again by removing the end carbon from the other end, in this case from this end. And so here I had 5 carbons. Now I'm only going to have 4 in the main or parent chain. I already had this branch here. And I'm going to take the carbon I removed and move it over 1, 2 spaces. So I'm going to add the hydrogens just to make sure I have the same formula, which I do. And then what you're going to do is name it. So this is a 4 carbon parent, butane, and this is 2,3-dimethylbutane. Now, when you have an alkene or alkyne, to draw the isomer, you can simply move the double bond. So let me show you how to do that with butene and pentene. Let's see if we can draw isomers of butene. But is the prefix meaning 4 carbons. Ene means there's a double bond. So I'm going to make a double bond between the first and second carbon. I'm going to add my hydrogens, making sure every carbon has 4 bonds. 1, 2, 3, 4, 5, 6, 7, 8. So this is C4H8. And this is officially 1 butene because the double bond is beginning on the first carbon and extending to the second. So the easiest way to make an isomer of a substance with a double or triple bond is to move the double or triple bond. So I'm going to start with my 4 carbons, and I'm going to move that double bond over 1. I'm going to add in the hydrogens, making sure that I add a total of 8, and I give this a name. So this is called 2-butene. So same formula, different names, different shapes, and different properties. Now you have to be really careful because if I go and I move this double bond again, and I think I'm making an isomer. So if I move it over here and I need to name the structure, remember that I have to always number my compounds from left to right. So that's like this, and from right to left. And so this multiple bond either starts on carbon number 3 or starts on carbon number 1. 1 is lower than 3, so we're going to remove this number scheme so we don't get confused later. And so this is called 1-butene, the same as the original. So these are not isomers. This is just the mirror image of that, and they are the same. The final example we want to work through is called 1-pentene. So the prefix pent tells us I have 5 carbons. And the ene says there's a double bond on carbon number 1. So I'm going to extend it here. And I'm going to add in my hydrogens, making sure that all of the carbons have 4 bonds. So this is C5H10. And to make its isomer, I'm going to start with its parent chain. And I'm going to take its double bond and move it over. So this is also C5H10. But this is called 2-pentene. So different name, different structure, different properties. When moving your double or triple bond, make sure that you are moving it to a new numbered position, and make sure you check your positions by numbering the carbon chain from left to right and right to left to make sure you've not actually moved it to the exact same position. So by now you should be able to identify isomers of alkanes, alkenes, and alkynes, and construct the isomers of alkanes, alkenes, alkynes. This concludes lesson number 64. Make sure you've taken good notes, complete your homework, and I'll see you in class.